Okay, guys, so here we go. Pre-calculus, chapter 9, section 5. Homework is going to be on 649. And in this lesson, we're going to talk about what's called the binomial theorem. And basically, what we want to do is use the binomial theorem to compute coefficients and write binomial expressions. Okay, it sounds fancy, but not that bad. We're going to use this right here. It's called the binomial theorem, and to expand powers that are kind of big. Okay, a couple of things you have to remember here is NCR, n combination r is n factorial. On the bottom of that is n minus r factorial and times r factorial. Okay, and then for binomial theorem, the binomial theorem is going to be, if you want to expand, if you want to write out x plus y to the nth power, it's going to be the sigma of r equals 0 through n of n factorial, n minus r factorial, and r factorial on the bottom, x to the n minus r, y to the r. Okay, so this is a big fancy formula that you got to get used to doing. All right, but right here, this fraction is the NCR, okay, combinations that you've seen before. Hopefully you remember it. We'll discuss it a little more. Basically, to find the nth term, any term you want, let r be n minus 1. Okay, so this is an important statement here. You want to find the nth term, you're going to let r be n minus 1. Okay, so we'll do some examples on that. Okay, so for example, first, let's talk about real quick, okay, something like 9C3. This is a refreshing of combinations that you should know. 9, choose 3. You have 9 items and you're going to choose 3 of them. For example, you have 9 marbles in a bowl and you're going to choose 3 of them. So how many ways are there to choose? Okay, so 9 factorial. On the bottom is going to be 9 minus 3 factorial. And next to that, 3 factorial. Okay, so when you work this out, 9 factorial on top, on the bottom 6 factorial, and 3 factorial. So when you expand this out, it's 9, 8, 7, 6, 5, 4, 3, 2, and 1. That's what 9 factorial means. You start at that number, you go all the way down to 1. On the bottom, you start with 6. So 6, 5, 4, 3, 2, 1. And then 3 factorial is 3, 2, 1. Okay, so here's your fraction. These are all being multiplied together. In other words, you can start canceling. Okay, 1 cancels 1. 2 cancels 2. 3 cancels 3. Okay, see how we cancel on top and bottom, whatever they have in common. We also have a 6 cancels 6. 5 cancels 5. 4 cancels 4. And then here, what we have is 3 goes into 9 3 times. 2 goes into 8 4 times. And so what we have is 4, 3, and 7. So there's 84 combinations. Okay? When you're doing combinations, it's order. Order in a combination, order matters. Okay? If you were to have 9 runners, okay, and there was a first, second, and third place winners, well, there's 84 different ways that 9 out of 9 runners, you can have 3 winners of first, second, and third. That's what 9C3 is. Okay, so make sure you're okay with that. We can do any amount. So let's say, for example, 12C4. Okay, again, for example, we have 12 people running a race, and there's 4 winners in this case. Okay, so again, it's 12 factorial, 12 minus 4 factorial, and 4 factorial. Okay, so we get 12 factorial, 8 factorial, 4 factorial. So 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. On the bottom of that, you have, see, I like to put over here, 8, 7, 6, 5, 4, 3, 2, 1. That's what 8 factorial is. And then I like to put the 4 factorial on the front end. Okay, 4, 3, 2, 1. So right here, what I did that is that all of these will cancel. So that's nice and neat. And so if you look at this, 3 times 4 is 12. So that goes away, right there. 2 goes into 10 5 times. So the only numbers we have remaining is 11, 5, and 9. Okay, so 11 times 5 times 9 is going to be 495 different ways that we can have 4 winners out of a race of 12 people. So that's called combination. And we're going to be using that to do binomial expansion. So hopefully you remember that part. Okay, so let's use our binomial expansion here. Okay, to work this, expand this. Okay, basically we want to be able to write this all out. What happens when we take this to the 8th power? Now there's a couple ways. Okay, we can write this out 8 times and FOIL it all, but that's a lot of work. You know, a lot of work, a lot of chances of making a mistake. Okay, but if we use what's called the binomial expansion, then we can use a sigma of r equals 0 up to 8. Okay, so, and then our first term, well, it would be 8 factorial over 8 minus r factorial and r factorial. And then the first term will be x to the 8 minus r and y to the r. Okay, so now we're going to use this formula, but the thing is we're going to let r be 0 first, and then 1, 2, 3, 4, 5, 6, 7, 8. Okay, so one at a time. We're going to do 0 first. Okay, so when we plug in 0, and this seems like a complicated process, but we're just doing the same thing over and over. Okay, but we just let r be 0 first. So 8 factorial, 8 minus 0 factorial, and 0 factorial. And then x to the power 8 minus 0, y to the 0. Okay, now something you need to know about 0 factorial. 0 factorial is always 1. Okay, so be careful of that. Now you have 8 factorial over 8 factorial, and then this is 1. Okay, so x to the 8th, y to the 0. So what does this give you? Okay, this gives you 1 times 8, x to the 8th times 1. So this is x to the 8th. So my first term is x to the 8th. I'll write that right here. Okay, now we're going to do it again. We're going to repeat this process, but we're going to let x be 1. Okay, 8 factorial on the bottom is going to be 8 minus 1 parentheses factorial, and on the bottom 1 factorial. Okay, then x would be 8 minus 1, y would have power 1. So on top you have 8 factorial, on the bottom 7 factorial, 1 factorial. Okay, and then x to the 7th and y to the 1. Okay, so now what's 8 factorial divided by 7 factorial, 1 factorial? That gives you 8, x to the 7th, y. Okay, so plus 8x to the 7th, y. And so you do it again. Now, see, we just did 2 things. We did r equals 0, r equals 1. We go all the way up to 8. We don't stop until we reach 8. I know it's a long process, but the work is very easy. Okay, 8 factorial, 8 minus 2 factorial, and 2 factorial. X to the, that's a times, sorry. X to the 8 minus 2, okay, the first number goes on the power of x. Y to the second number, 2. Okay, so we work this out with 8 factorial, 6 factorial, 2 factorial, x to the 6, y squared. Now 8 factorial divided by 6 factorial, 2 factorial is going to be 28, x to the 6, y squared. So plus 28x to the 6y squared. So what you notice is that first my x power is 8, then it's going down to 7, and it's going down to 6. But my y is growing. I had y to the 0, y to the 1, y to the 2. And if you notice, look at these two powers. If I add them, I get the whole power of 8. Okay, 7 plus 1, 8. 6 plus 2, 8. So x is going down, y is going up. Okay, again, I'm going to do it again with r equals 3. So 8 factorial, 8 minus 3 factorial, and 3 factorial. X to the 8 minus 3, y to the 3. So 8 factorial, 5 factorial, 3 factorial, x to the 5, y to the third, sorry. Okay, 8 factorial divided by 5 factorial divided by 3 factorial is going to be 56. X to the 5th, y cubed. So I put here plus 56, x to the 5th, y cubed. Okay, again, notice the x is going down in powers, y is going up. But anytime I take a term, I add them, I get 8 because my whole power is 8. 7, 1, 6, 2, 5, 3. My next one, if you guess, is going to be 4, 4. Okay, because x is going down, y is going up. So let r be 4. 8 factorial, 8 minus 4 factorial, 4 factorial, x to the 8 minus 4, y to the 4. Okay, so 8 factorial, 4 factorial, 4 factorial, x to the 4th, y to the 4th. Now, what's 8 factorial divided by 4 factorial, 4 factorial? This is going to be 70. Okay, 70 x to the 4th, y to the 4th. So that's my next term, 70. X to the 4th, y to the 4th. Okay, again, I did 0, 1, 2, 3, 4. I got to go 5, 6, 7, and 8. Okay, so when I do that, by the time I'm done, I'm going to have this thing all expanded out. That just basically, I'm taking x plus y to the 8th power. Okay, and I expand it all out. So you need to finish this, and hopefully you can do that, right? So keep on going. Do this again when r equals 5, then r equals 6, r equals 7, r equals 8. Okay? And what you should get when you're done, the 5th term, actually 1, 2, 3, 4, 5, the 6th term, okay, will be 56, x to the 3rd, y 5th, then it will be plus 28, x squared, y 6, plus 8, x, y 7, and then my last term, y to the 8th. Okay, so this is the entire problem all expanded out. All right, hopefully you're okay with that. All right, so we're done with that example. We'll do some more examples, okay? So a different type of problem that you might see is they're not going to ask you to expand the whole thing out. They're going to give you like this. They're going to say, for example, find the term, okay? Find the second term of 4x plus 2y to the 5th power, okay? So a couple ways to do this. I can take this, write it out 5 times, and foil it, and it's going to take a long process. But they only want the second term. Now, if you remember, my first term is r equals 0, right? My second term, this is my first term. My second term is r is going to be 1, right? So term will always equal r minus, well, n, okay? R equals term minus 1. So let me rewrite that. R equals term minus 1. So let me rewrite that, okay? So whatever term you want, r is going to be that number minus 1. So if I want the second term, then I'm going to let r equals 1. second term. So r equals second term minus 1. So 2 minus 1, 1. So what I'm going to do now is I'm going to have r equals 1 into that big fancy formula, 5 factorial, 5 minus 1 factorial, and 1 factorial. Then 4x to the power 5 minus 1, 2y to the power 1. Okay, 5 factorial over 4 factorial, 1 factorial is going to be 5 times 4x to the 4th power and 2y to the 1st. Okay, so this is 5. 4 to the 4th power is going to be 256. X to the 4th, 2y. So now just multiply this together. 2,560 x to the 4th, y. That's it. This is my second term. Okay, so this is just when they want a certain term. That's all that is. Okay, one more example of that. Let's say I have 9x plus, let's say, 4y to the 8th power. And here I want the seventh term. Okay, again, remember, 7th term. Okay, r equals term minus 1. So r equals 7 minus 1, r equals 6. So I want basically this, let this equation be used when r is 6. So when r equals 6, I'm going to have 8 factorial, 8 minus 6 factorial, 6 factorial. And then 9x to the 8 minus 6, 4y to the 6. And so you just got to evaluate this and you'll get your answer. Okay, so here, 8 factorial divided by 2 factorial, 6 factorial, it's going to be 28 times 9x squared, 4y, 6. Okay, so 28 times 81x squared times, okay, we're looking at 4 to the power 6. Okay, this is 4,096. Okay, so multiplying all this out, you're going to get times, when you multiply these three numbers out, you are going to get 9,289,728 x squared y 6. So there you go. All right, so this is what they call the 7th term. Okay, so hopefully it would do that. All right, try it on your own.